Let me wash my hands.
Hi. Today we would like to see this coding problem of palindrome checking. So in this problem, so we will be given a string. And what is a palindrome basically? So if you reverse the string, given string from back to front, from all strings need to be reversed. So
Well, it's there.
if the given string and the reversed string are equal, so if they are equal, then it is a palindrome. So if you see A and A is equal, B is equal, C is equal, and this is B. So this is a middle element. This is odd odd length of the given array. So this would be still there. So this is a palindrome. This is palindrome. Okay. So how will we proceed for checking mm, programmatically? So one of the ways, as we just talked, that the definition of the palindrome is if you just reverse that string, if the given string, if it happens to be the given string and the reverse string became equal, then obviously it is a palindrome. So okay, so what are the time and space complexities for reversing a string? So for reversing a string, we need to uh, through this, iterate through this, and we need to create a something like a new string, empty string, and add a new character every time to that string. So something like this. So I will create new is equal to empty string, and I will append. I will iterate through the string each character, and just I will update string one of I, where I mm, like I ranges between the last index to first index. Okay. So what happens here is, what is the time and space complexity for this? If okay, well, finally we will check if the new string and the given string are equal, just return it's true or always false. Okay, so what are the time and space complexities for this? What is the time complexity or space complexity? So we are iterating once through this string, input string. Hmm. That would be a for loop above, and that is one n times big O of n. And what is happening here is every time you are concatenating to the already existing string with a new character. So what it will do is, this concatenation actually is, say for example, if ABC is there already in the new string, so D is being added. So what will happen is, it will check, so A, B, C, and finally it will add as D. So that is an iteration. So this string concatenation, every time a new string will be created, and this will happen in big O of n time. So finally, big O of n and big O of m will make it big O of n square, when where n is the length of the given input string. And what are the space complexities for this? Space complexity is just, we are creating we are just creating one string, right? New string. So that is big O of n. Okay, so we can implement like this. Implementation part is, definition is palindrome, and we'll take the input string of string 1, that is the input given string, and create a new empty string, and iterate through the indexes back to front of the here one thing. So if it is range, hmm, we can given two ways for stating that the index need to start from back to front. We can give like range length of string 1 minus 1 and go to up to 0. This minus 1 is not considered, with an increment of minus 1. So we can tell like this, or just simply you use reversed within the general range length of string 1. So that's it. So this will iterate from back to front. So we started iterating through the given string, and as we talk, we need to append every character to this. Plus 1 is equal to string 1 of I. We created the new here and just written is new. The newly created reverse string is it equal to the given input string. If that is the case, it's a palindrome. So that's it. This executes in big O of n square and big O of n. So can we make any modifications or improvement to this? Yes, definitely yes. Okay, what improvement can we make? One important improvement that can be made here is, so we are concatenating with a new string because we have taken the initially a string. What this is creating a big O of n time complexity. So to remove that big O of n square and make it big O of n, what can we do is we can just create a list initially instead of the string. Just create a list. This need to be a little bit modified because if you're starting with a list, if you're starting with a list and you're gonna append the new character, new dot append, this is Python, so append will add new character to that list. Append the string 1 of I. So now this will contain these characters in a reversed order, but in a list, not in a string. So finally, what you can do, say for example, if ABCD is there, this will become here. It will be present like this: B, C, D, C, B, A. So just make it concatenation. How can we concatenate? Just single empty string join. You need to pass join a iterator inside this. The iterator is the list, the new one. This will make this will just add all these into a string by placing the empty string or empty string, maybe you can call it empty string, between these characters and join that, and we will just return this equal to the string one. So that's it. So regarding this, this is just iterating in big O of n. This is a little bit improvement for the older one. So what we have done, we have created a list and joined through the empty string here and returning whether the given string and the newly created reversed string both are equal or not. So okay. So we are talking about the iteration methods. So is there, we can do like in a recursion way too. Currently we have this big O of n. Yeah, here one new string, new list is created, Mm, so so that is of big O of n complexity. So we can, these two methods which we just discussed were iteration methods. So can we do it in recursion way, this palindrome? Okay, so if the recursion is there, how can we proceed or approach to this? So how will you approach is, we will, instead of iterating through this, we will just check, okay, whether the first letter and the last letter are both equal. If that is the case, move to the next one. So just compare the mid ones. So recursively make a call that whether the first one and the last characters of any mid strings are equal, or palindromes or not. That will execute in a time complexity of big O of n, because we are just iterating. Uh, so this length of the time, it's not iteration. We are doing some looping for n by 2 times, because if this is the length of n, and we are just comparing from this end and from that end, so we have reduced the length of the loopings by n by 2. But obviously big O of n by 2 is just big O of n. So yeah, this is recursion way. So the space complexity, in recursion too, the important thing here is, in iteration have seen that, okay, we are creating a new lists or new strings. But in recursion what will happen is, it will create uh, like like a stack where the function calls would be present. Say if uh, a b, if a is palindrome check has been made for this given string a b c d c b a, and on the top of it, after checking the this first and last characters, it need to check the removing those characters. So there will be a top call on that top function call on bcd cb. So again, after checking the first and the last characters, so it will again check the mid characters c c d c. So it is actually like uh, making the calls and the call stack each frame. This is called in a function call stack. So each new frame will be added. So finally d, and this also creates a like some memory for that. This is of length of, so what you can say, it is of big O of n by 2, which is obviously big O of n memory. In recursion also there will be memory because of this kind of call stacks, not only in iteration. Okay, so how will we this is recursion. In recursion we have got big O of n with n by 2 times looping, and which is time complexity of big O of n space complexity, because of the function stack. So big O of n. So how will we implement the recursion way? So definition is palindrome, which will take this string one, and we need to, for this I think we can just put like this: for I is equal to initial index, I is equal to 0, j is equal to, what is the j, the last character, I mean ing is the first and last, I mean. So length of string 1 minus 1, that is the length of, that is the index of the last character for this string, this. Okay, so I and j characters are there. So what we can check, so we can check the first. Hmm, okay, I will do like this. We got the I and j, and we need to just check the first character. If the first character is string 1 of I, string 1 of I, is it equal to the string 1 of j? That is the main thing, isn't it? So um, the first character and the last character. Hmm, and one more thing we have to put condition here is we are checking these characters, but we need to check the condition of the condition between, I mean, I less than j or whatever. So so it is obvious that if we are going, we are reducing this one, we are increasing the I and decreasing j. So at some point, either if the string is an odd length of the string, I and j will be equal at some point of time, provided the string becomes, all the characters up to here became equal, and finally I and j become equal here. Okay, so in that case we need to add one more check, that is I less than or equal to j. So this makes sure that the first index is always less than or equal to the index which is coming from the back. um, and this is checking this I less than or equal to j. Okay, like this, and still we need to make any additions to this function, to this condition I less than or equal to j less than, and we are checking the first and last character, and we need to, what we call, we need to call the next increment the I by 1, isn't it? And we will, as this is a recursion, we will just call this function again, and is palindrome. This will take actually the string 1. So it will still take the string 1, but a modified string. I think this string, then I incremented by 1. I incremented by 1. So in that, if that is the case, this parameter need to be present over here. So these are the three conditions that he checked here. Okay, just one moment here. So did we write j is equal to length of, is this correct? I think this had to be added minus I because why? Because so if it is 0, this is okay. Minus 1. So but if it is 1, it need to be the j need to be decremented by 1. So minus I should be there here. I and j and I less than or equal to j and this strings front and back and recursively calling that function with new incremented I plus 1. So I think that's it. So rewriting this again in a clear manner, we got this I, we got this j, just return check initially whether I less than or equal to j because that is initial thing, and we need to check whether the characters are equal or not. String 1 of I is equal to string 2 of j, and what you need to call, you need to, as this is a recursive, you need to call the uh, next looping or kind of. So this need to call is palindrome the same function palindrome. So the string one but I plus 1. What will happen when this is executed? When I plus 1 is executed, this I becomes 1 and j becomes I becomes 1 and j becomes this. So this will be checked whether this character at string excuse me, string 1 of 1 is equal to string 2 of this character. Are this equal? Initially check this. So this will return true or false, and this will create uh, a function stack, a call stack, which each frame present on these are frames. Okay, so this is doing the recursion in big O of n time, just looping n by 2 times, which is of big O of n time complexity, and this is creating this call stack, which is of big O of n by 2, which is equal to big O of n. Okay, so we talked about recursion and previously iterations. Now, okay, now we will still see what is the anything we can do, still the improvement for this. Yes, we can definitely do improvement for this. So say we can still do the improvement for space complexity and make it bigger of 1. Okay, so how can we do that? We need not to even create an array, or I mean, yeah, we need not to create a list or a string. Just take 2 pointers, the left pointer and right pointer, and just move the pointers. So in that case, you are not even creating any list or array. I mean, list or string. So this will become bigger of 1 time complexity. So how will we proceed um, that way? So again, so definition of is palindrome, which takes this string one, and what it needs to do primarily. So as we talked, it needs to create the left pointer and right pointer. So I will call just like left pointer is something index to pointer which is initialized to 0, initially, and right pointer, right index, I mean. So that will become equal to length of string 1 minus 1. Okay, so length, left index and right index. So what is the basic check we need to do for iterations? Um, while I am going to just make a while loop and make sure the left index is less than the right index at any time. Okay, and if the left index and right index is less, so what you need to check, if for the string 1 is left index not equal to string 1 of right index, so return false. Return false. Or this happens only when these characters became equal, and obviously whenever this condition is hit, it will just return the false for the palindrome. It won't even check for the other characters. But if this not equal to is not happened, so what you need to do, you need to go further, like increasing the left index by 1 and decreasing the right index, reducing by 1. So what will happen, this will all happen, and it will all go up to left index less than right index. And at a point where it became uh, the left index became greater than, or actually greater than or equal to right index, so that means all the checkings has been completed and the characters became equal. So then you just need to return as true, stating that this is a palindrome, the given string is a palindrome. So if you see, we are just iterating one time, which is a time complexity of big O of n, and time complexity is big O of n, and space complexity, there is nothing we are storing, we are just directly accessing the string characters using the indexes or pointers. So it is of space complexity as big O of 1. So these are the few ways that we can solve this problem. So I think that's it for this.